All right, let's talk about a really fascinating and, frankly, a really tough problem in the world of data. How in the world can you make data permanent and totally secure, but also have it be lightning fast? Today, we're going to break down how Codatta's architecture tries to solve this puzzle. Okay, let's get into it. So here's our game plan. We're going to follow a single piece of data on its journey all the way through the Codatta system. It's a six-part story. We'll start with the big problem they're solving, see how the data gets locked in permanently, then how it's made fast, how access is controlled, how it's processed in a super secure way, and finally, we'll look at the unbreakable promises that make the whole thing trustworthy. So let's kick things off with that fundamental challenge. In data systems, there's always been this nagging trade-off. It feels like you can have durable data, you can have private data, or you can have fast data. But getting all three of those at the same time, that's been the holy grail for a long, long time. I mean, just think about it for a second. What's your priority? Do you want your data served up instantly, like you get with a typical cloud service? Or do you want it to be permanent and impossible to tamper with, like it's been carved into stone? Or is total privacy and security the most important thing? Historically, you've pretty much had to pick one and sacrifice the others. Well, Codatta's whole argument is that you don't have to choose anymore. The answer isn't to pick one, it's to build a totally new hybrid model that's specifically designed to give you all three. So the big question is, how on earth do they pull that off? Let's follow the data and find out.
Okay, so step one, and this is like the absolute bedrock of the entire system. The very first thing that happens is the data is made permanent, and it does this by anchoring it in something they call a source of truth.
And this slide just lays out the core idea so perfectly. It's a hybrid, right? So on one side, you have this Web3 source of truth. The best way to think of this is like a certificate of origin for your data. It's the official, undeniable proof of what it is and where it came from. Then, on the other side, you have the good old Web2 hot paths, which are like your local warehouse. Not the official record, but the place you go to get what you need, fast. Two different worlds working in harmony.
So what is this source of truth really? Well, it's a decentralized storage layer. It uses technologies you might have heard of, like Arweave or IPFS and Filecoin. Instead of storing your data on one company's server, these systems scatter it across a global network and use cryptography to lock it in place. That's what makes it immutable, which is just a fancy way of saying once something is written, it can never, ever be changed. This becomes the ultimate, undisputed, permanent record.
But here's the thing about permanent storage. It's not always super fast. So once our piece of data has its forever home, the next big challenge is, how do we get to it instantly? And that's where the other half of this hybrid model kicks in. Enter the hot paths. Now, these use technologies that are probably super familiar to a lot of you, high-speed cloud storage like Amazon S3 or Google Cloud Storage. They basically act as a super fast cache. They hold copies of the data or even just little slices of it that you're going to need to access really, really quickly. This is what gives you those speedy, low-latency reads. But here is the most crucial part of this whole setup. You got to get this. The relationship between these two layers is everything. That fast cloud cache, it's just a temporary copy for convenience. It always, without exception, points back to the permanent record in the source of truth. So the hot path gives you the speed you want, but it's the Web3 layer underneath that guarantees the data's integrity. It's the best of both worlds. Okay, so our data is now both permanent and fast. That's awesome. But who gets to actually see it? We can't just let anyone in. So the next stop on our data's journey is the security checkpoint, a really smart, policy-driven access gateway. You can think of this gateway as the bouncer at an exclusive club. It checks every single request at the door against a list of rules. For example, it can give you access based on your role, like, are you an admin? It can check specific attributes, or it can even do something really cool, like grant access if you hold a specific crypto token in your wallet. Oh, and by the way, it also keeps a tab on everything for billing purposes. Now, this next part is really cool. What if you need to do something with really sensitive data, but you're not actually allowed to see the raw data yourself? This is where the next layer comes in. Think of it like being able to do your work inside a locked safe without ever having to open the door. And here's how it works, broken down into 4 pretty simple steps. First, a request comes in for a sensitive operation. Second, the gateway sends that request not to a regular server, but to a special, secure black box called a Trusted Execution Environment, or a TEE. Now, here's the magic. Inside this safe, the data is processed while it is still encrypted. The raw data is never exposed. And finally, only the safe, authorized result gets sent back out. And this isn't just a one-trick pony, you know. This secure approach can be used for all sorts of things, like automatically redacting private information like names and addresses from a document, or for something like federated machine learning, where you can train AI models on data without that sensitive data ever having to leave its original secure home. Super powerful stuff. So we've seen the whole journey now, from start to finish. And that brings us to the final and maybe most important part, the fundamental guarantees of the system. These are the core promises, the non-negotiable, unbreakable rules that the entire architecture is built on. There are 4 of them, and they are ironclad. Rule 1, source of truth always comes first. The cloud cache is the servant, not the master. Rule 2, every single byte of data that gets served is traceable all the way back to its origin, no exceptions. Rule 3, the system is built for minimal disclosure. It only reveals what is absolutely necessary and nothing more. And Rule 4, every request is replayable, which means you have a perfect, consistent, and auditable trail of everything that's ever happened. And this quote from their own material just sums up the ultimate benefit perfectly. Because every byte is tied back to its origin, what they call a contribution fingerprint, or CF, which is kind of like a unique DNA fingerprint for data. The whole system of where data came from, who used it, and how it should be built becomes completely transparent and explainable. There are no black boxes. This whole thing really leaves us with a final, massive thought. This architecture isn't just about a bunch of clever technical tricks. It's about creating a foundation for verifiable, trustworthy information. So the question I'll leave you with is this. If every single piece of data we used online, every article, every image, every dataset had a clear, unbreakable, and traceable origin, just what would that change about our digital world?